Now, worst case scenario is if they do not tell you anything at all about the kind of conic that you have. So how do you tell what's happening? And so to be very generic, you've got some comments here about things, but let's try to boil this down to some more useful comments to make. If our x squared and our y squared stuff have the same number out in front, we've got a circle. If our x squared and our y squared stuff is added together but different numbers, then it's going to be a conic that's an ellipse. If our x squared stuff and our y squared stuff is subtracted together, whether it has the same number or not, then we've got a hyperbola. So, sorry, I should probably be a little bit more clear about the circle stuff. X squared stuff, y squared stuff has to be added and have the same number in front. That leaves us with the parabola. Well, what's the parabola? Well, the parabola is the only one of these that doesn't have both variables squared. So if one variable is squared and the other one is not, that's automatically going to be parabola. Now, the eccentricity that we've been mentioning is also something that we can use. And if we go back and take a look at our examples, an ellipse, the examples that we had with the ellipse all had eccentricities between 0 and 1. And then if that ellipse explodes, if the eccentricity explodes, then it would actually explode, as it happens, to a number that's bigger than 1. So that's another sort of relationship that we could use, but since we've seen that using the eccentricity is pretty rare, we're not necessarily likely to be confronted with that. If they do not tell us, we would want to use those comments to try to identify which thing we have, or we could start trying to work through and create one of our forms. That means that we're just kind of driving blind for a little bit. So it would really be better for you to try to connect with these comments. Circle stuff, x squared stuff plus y squared stuff, and they have to have the same numbers in front of them. So 16x squared and a plus 16y squared, great, got a circle. If my x squared stuff and my y squared stuff are added together but have different numbers in front, like a 16x squared and a 9y squared, now we're talking about an ellipse. If my x squared stuff and my y squared stuff have opposite signs, no matter what, that is a hyperbola. So 16x squared and a minus 16y squared, or 144y squared and a minus 169x squared. Anything where one of my variables is squared but the other one is not means that we've got a parabola. If we can identify the kind of conic that we're looking at from the equation just right off the bat like that, then that will automatically have us associating with the correct kind of equation. We'll know what kind of work we need to do. A little bit of completing the square, a lot of completing the square. How should that equation look when I'm finished and am ready to start working through the unshifted information? I need this, or I need that, I need this other things, depending on which. For a circle, we've got center and radius. For the parabola, we've got the vertex, the focus, and the directrix. For an ellipse, we've got the center, the vertices, the foci. We've got the length of the major axis, length of the minor axis. We've maybe not got the eccentricity. We would maybe want to make a comment in the case of the parabola, the ellipse, and the hyperbola about what it looks like. It opens this way, oriented this way, something to that effect. Hyperbola, again, we've got a lot of the same things that show up with the ellipse: center, vertices, foci. We've got the transverse axis instead. We've got the asymptotes as well. So narrowing down that list of information that we would want to generate depending on what exactly they throw at us without any additional indication of what that equation is supposed to work out to give us.